I am Stewart, and I'm with Aerometrex, and I'm here today to talk a little bit about high-resolution aerial 3D modeling and how this type of high-resolution 3D information can change the way organizations make business decisions leveraging this accurate 3D geospatial data. So just as a quick outline here for what I'm going to cover, I'll give a quick overview. And then I will also talk about multiscale 3D mesh modeling relative to the high resolution type of capture that we do here at Aerometrex, primarily helicopter based. And then also we'll talk about the street level, ground level capture that we do. And then we'll talk a little bit about the semantic level of detail modeling, classified 3D meshes. We'll talk a little bit about some of the different types of 3D applications that are utilizing this data. I'll cover hopefully a couple of projects that we've got going on in the US, and then a brief coverage of some of our business partners. So if you haven't heard of Aerometrex, if you're not familiar with us, we are an organization that has a long history, decades long, in aerial imagery, aerial LiDAR, and 3D modeling. And our 3D modeling products allow you to use this high-resolution 3D information for city mesh models to give you context for your projects, to help you to develop and visualize scenarios and simulations, as well as offering a base data set for your GIS or for monitoring changes. We have customers around the world and projects that we've done globally, especially in the United States, Australia, New Zealand, France, and Germany, just to name a few. And we work with multi-platform, multi-scale 3D models, and I will talk about what that entails, what that looks like. But it's the integration of the data that we capture using primarily helicopters, sometimes fixed-wing aircraft and drones, as well as the street-level data. And then we create, through the integration of those data sets, a seamless 3D mesh. And I'll show you some examples of that. And then also talk a little bit about how this flexibility and the way that we do what we do supports the various data formats for the software systems, CAD, GIS, et cetera, and some of the other hardware viewing systems that are out there. So the high resolution information is really where we focus the vast majority of our efforts, and capturing this additional information and detail at the high resolution allows us to deliver these high-res 3D reality mesh models. And as I mentioned, we capture primarily via helicopter, and we do this with the highest standards of 3D modeling and are working at sub 1 inch resolution and typically 2 inches of absolute accuracy. We leverage leading capture and processing technologies to produce these seamless, highly accurate and realistic 3D mesh, city mesh models. And we've done high resolution 3D products all over for applications that include urban design, town planning, civil engineering, asset management, emergency management, erosion mapping, tourism, visual communication. The list really goes on and on. And I thought I'd include a slide that gives you a quick look at what the process looks like from the air in one of our typical helicopter flights. And so we do this via helicopter because it gives us a platform where we really have the ability to focus capturing more detail and more information in the specific areas of interest, and that is very beneficial to getting the level of resolution and accuracy that we strive for. So photogrammetry is realistically just the basis behind what we do, and this is a decades old theory, but we've got a modern interpretation that we utilize in order to make this high accurate, highly reliable data that is basically using masses of oblique overlapping images And as I mentioned, this imagery typically is sub 1 inch in resolution and 2 inches of absolute accuracy. And then we can also incorporate imagery that's taken from other platforms, including conventional vertical aerial, as well as street level imagery. And in the processing side, we use some very advanced algorithms to extract out the detailed 3D information from the source imagery. And while some of that's automatically processed, we do employ some significant manual QA processes and fix that data and adjust that data as necessary to meet our clients' requirements. And I've talked about the street level as well, and that the street level capture is actually done from the ground and is photogrammetry or photogrammetric based. And the models that we can generate from this particular type of methodology really give us that next level of detail and give us models that we can incorporate and use in our GIS and planning environment. They're also a great asset for doing virtual reality or even some of the gaming environments. So this level of detail is ideal for applications such as immersive tourism, to showcase the areas that are of high interest, and it's especially well suited to display the character of historic buildings, their beautiful complexities and their nuanced architecture. And this is the level of detail that a lot of customers are asking for when it comes to using 3D for simulations and high-end visual communication. Multiscale 3D mesh modeling. This is another output option, another product that we can generate, and these 3D mesh layers are integrated into a geo-referenced 3D environment, and these hybrid 3D models are captured through different sensors and different platforms and are linked together to create a seamless mesh with multi-scale detail. This adds content and improves both the geometry and the visual quality of the 3D model by adding in 3D point clouds for that extra geometry information, which is reducing occlusions and distortions, as well as improving the resolution of the texture in those areas of interest. Another way that we can utilize the high resolution capture data is for 3D LOD, level of detail modeling, which is a representation of the buildings at different scales and with scalable detail. So we have the ability to separate specific elements such as individual walls, roofs, furniture, etc. And our flexible approach in how we capture this data and how we process this data means that we can adapt standard LOD levels, 0 to 3, to address the niche requirements of customers in a very cost-efficient manner. And we also offer a range of formats to suit any application and compatibility across 3D visualization, CAD, and GIS packages. And then we work collaboratively with our clients to make sure that we're offering the right solution with the right combinations of tools and processing to be able to meet their specific needs. Classified 3D mesh. This is another option that we can generate. These classified 3D mesh models have objects like buildings and trees that are classified from that 3D mesh so that they can be individually selected, highlighted, and linked right into your geodatabase directly in the 3D mesh. Greater computing power that we've seen as computer technology evolves along with the 3D format, which is now being supported by many major geospatial software solutions, allows cities to adopt a reality mesh 3D city model as their base data set for smart city planning. Using the interactive 3D GIS solutions, users can interact with and query the integrated classified 3D data, and that opens up an entire range of new possibilities for using this type of high-resolution 3D data. There are many, many different types of applications that can use 3D information, 3D models, and as this technology continues to evolve very, very quickly into the 3D representations of the world around us, This type of highly accurate, detailed model that we specialize in here at Aerometrex allows organizations to better interact with the part of the world that they're responsible for managing. So you can see and dynamically share with your community new developments as they're designed and constructed. You can create virtual reality simulations. You can perform extensive analysis and measurement of existing and proposed projects. You can detect and monitor changes over time. You can generate a view of the future, or you can capture some of those foundational components that are utilized commonly in 3D films and gaming. So a lot of different applications even beyond this, but this is just to name a few. So this video that I've got here is a quick example of a localized cultural heritage project, and it was designed to be a piece of a larger 3D model. I'm going to go ahead and play this so that you can see just one example of what this high resolution data can look like. This was captured back in July of 2015. This was leading up, I believe, to the papal visit to be able to model the entire space for the routes that the convoy, the vehicles would pass through, and to be able to three-dimensionally analyze all of the space for the crowds and everything else in a very dynamic visual manner. But then you can also see that the level of detail that's captured is very significant and allows this information to be used in a lot of different ways. We can take this ground level data that we capture and integrate it seamlessly with the data that's captured from the air, so that it is very, very seamless. It's all just flows together, and with whatever perspective you're using to view this particular structure or this area, it flows really nicely and comes together well. So that's just one example of a project that we've done here in the US. We have some others, San Francisco and other areas that we've done. The next video that I've got here is a video of a project that we are just finishing up, actually, in the Denver area. And this particular project is almost complete. So what we're looking at here is another project similar to the Philadelphia information that was captured in a localized area at high resolution, designed to be integrated in to a larger 3D model. You might recognize some of the landmarks in the area. If you've been to Denver or familiar, you'll see Coors Field will show up here in a little bit. But this is just an example. Hopefully this is rendering well through the internet connection and through to those of you viewers. But the level of detail and the level of resolution is so useful for a lot of different directions. Whether you're a city planner looking to share data with the community or the council, whether you're a GIS professional looking to be able to zoom in and extract features and information from this 3D model, there's a lot of different ways that this can be utilized. This data has been processed roughly. It has not been finalized. We have a fairly extensive manual QA process that we go through to finish this out and to make it perfect. You might see here on the roof of the Coors Field some artifacts there that would obviously be cleaned up prior to turning this into a deliverable. But it's just an example of how we seamlessly put together different levels of data: 2 centimeter data, 5 centimeter data, high resolution street level information, as well as the aerial data. So That's probably adequate there. We'll actually we'll let it zoom in on the front of course field before I click this off and go on to the next slide. So like most companies, Aerometrex can't accomplish what we do all on our own. We work with a number of great partners to ensure that our data can be used in the industry standard CAD and GIS software suites, as well as 3D visualization software and gaming engine. And this is just kind of a quick list of a few of those organizations that we work closely with in order to be able to provide the deliverables and the products that we offer up to our clients. So that pretty much sums up what I wanted to present, and I will go ahead and stop the sharing and turn this back over to Mark. There may be some questions on the Q&A. I'm happy to help address any of those to the best of my knowledge and ability. If we have some, go ahead, Mark.
Thank you, Dale. Appreciate that. So you just touched on it there right at the end. We had a question about what's deliverable data formats. Can you expand on that?
Yeah, and I am actually brand new with the company, so this is like my second week. We do offer in the data, to my knowledge, in most of the industry standard 3D model formats. So OBJ is one of them, and there are several others. So this data can be brought into Esri's software. It will go into Revit as well. You can use this data in the Skyline suite of products, and so I apologize, I don't have the full list of all of those different formats, but it's pretty much universally compatible with most everything that's out there.
You had some beautiful images of the Philadelphia heritage areas. Is that a focus of something that Aerometrex is focusing on as far as trying to?
Yeah, not specifically. That just happened to be a project that we were brought in to do, and the Denver is one that we are just wrapping up now. And so some of our projects are very client specific. Some of those projects, the client retains the data. Some of those projects, we retain that data, and then we have the rights to that to be able to offer that information up for people who want to view it or utilize that.
Okay, very good. So there's another one. What's the typical horizontal vertical accuracy of a model when different resolutions are integrated?
And that's a good question. I would probably defer that question to one of our technical experts. And we normally will georeference our data down to that 2 centimeter level. The 5 centimeter resolution data, I haven't looked at the specifics on that as to whether that still falls within our typical 2 centimeter accuracy, absolute accuracy, or whether that ends up with a different level of accuracy specific to that portion of the data set. So, but I'm happy to find out, and if you've got the information for that individual that asked that question, I'd be happy to pass that along to them or to you to forward to them.
Okay, very good.